In the following problem, we're looking at a special decision on whether to continue making a component or to buy it from an outsourced supplier. So we have a company, they're making tools, and they've given us the details for how they currently make these tools. Right now they're making 14,300, and they have a company who has offered to make these same tools for a price of $32 per tool. It's also important that this outside supplier can provide all of the tools that they're currently making. So this would mean that if they move to the outsourced supplier, they wouldn't be making any of these. Sometimes we'll see we may have a possibility to outsource, but maybe the supplier can't provide everything that we're making. In this case, that's not an issue, but let's say they told us they could only make 13,000 of those. In that case, we'd need to calculate the price of buying the 13,000 and then the additional cost of what it would take us to make the other 1,300 that we need. So again, we can expand this problem, but this problem is fairly straightforward as it's written. We've got information about our per unit costs, and then we were also given those costs in total. We were told that there was direct materials, direct labor, variable manufacturing overhead, and we had fixed overhead. Some of it was traceable and some of it was allocated. And then below they tell us out of the traceable fixed manufacturing overhead, 40% is supervisory sales and 60% is depreciation. The supervisor positions will go away if we're no longer making these tools or these parts. So let's look down below and look at our requirements. Assuming the company has no alternative use for their facilities, if they were to outsource, okay, what would be the benefit or the detriment? So as we look down here below, I've got a table, and in my table I'm calculating the differential costs. Now, as I've started going through and looking at homework or dealing with questions as they come in throughout the week, I have some people who are struggling with understanding differential cost and total cost. I've approached this using the differential approach. You can also approach these problems using the total cost approach. Both methods are going to come up with the same answer, because we're looking at the difference between either the differential costs or the difference between the total costs. But you need to be careful with how you title this and whether or not you understand the difference between differential costs and total costs. Differential costs, I'm only looking at the costs that differ between my two options. Total costs, you're going to include the total cost of each method. The total cost of making versus the total cost of buying. So then over here I've explained, and you weren't required to do this, but just for the ease of going through this, I've explained why something is or is not a differential cost. So if you did this through the total cost approach, you should really change your title right here. Instead of calling it differential costs, you would say total costs. So let's talk through this. What I've done is I've made a column for the differential cost to make versus the differential cost to buy. The differential cost to buy is the fact that if I buy this, it's going to cost me $32 per unit. This is a differential cost because the cost differs between my two scenarios. If I make this myself, I don't incur this cost. If I buy it, I do. So we could call this a differential cost. We could also call it an avoidable cost, because if we make it, we avoid this $32 cost. Now, we incur other costs if we make it, but if we choose to buy it, we avoid certain costs. If we choose to make it, we avoid other costs. So in this case, if we buy it from the outsourced supplier, the differential cost to buy it is $32. Then I look at the differential cost if I make these. If I make these, I'm going to incur $9 per unit. If I buy these from an outsourced supplier, I do not incur this cost. So this entire $9 is a differential cost because I can avoid this cost if I buy it from the outsourced supplier. I incur the cost if I make it. Now, if you use the total cost approach, you would still have this $9 right here, because in this case, the differential cost is the total direct materials cost. So right now the differential method and the total cost method, they don't differ yet. The same is true with direct labor. If I make these, I incur all of my direct labor of $11 per unit. So again, if you're using the total cost approach, you'd have $11 here for the price to make it versus no dollars if I'm buying it. Then we look at variable manufacturing overhead. If it's $3 per unit and I'm not making any of these, I would totally avoid that cost. So here, my variable manufacturing overhead, the entire $3, the total cost, is a relevant cost. So $3 if I make it, nothing if I buy it. So again, if you're using that total cost approach versus my differential approach, so far the two methods are the same. Where it's going to be different is down below. Now, what I've done is I'm only looking for my fixed manufacturing overhead, the traceable and allocated portion. The only parts that I put into my chart are the differential costs. So let's look up here. With my traceable overhead is $6 per unit. And then I'm told that 40% of that is supervisor salaries and 60% is equipment depreciation. You know from reading that depreciation is always a sunk cost. That's another way of saying it's always irrelevant because it does not differ. That means if I make this product or if I buy it, I still have that depreciation cost. So that depreciation cost is irrelevant. It is not differential. So when I'm using the differential approach, I ignore the 60% of this $6. Meaning the only portion of this $6 that is a relevant cost or that differs between my situations is 40% of $6. And you can see 40% of $6, you can see my calculation there, is where I came up with my differential cost of $2.40 per unit. Now this is where the differential approach and the total cost approach are going to be different. I'll show you what it would have looked like if you used the the total approach, which again, either method is fine, but you do have to be careful how you title this. I had a lot of people who used the total cost approach, but yet they called these their differential costs. These are, in fact, my differential costs, what you see here. In a minute, I'll adjust this to the total cost approach, and you'll see that it's a different method, same answer, but we've got to be careful how we title things. Down here I've got my fixed manufacturing overhead, the allocated portion. Allocated fixed manufacturing overhead means it's total overhead and it's being allocated to all of my products. If it's allocated overhead, it means whether or not I make this specific product, my total allocated overhead will stay the same. So although this $13 is not going to be applied to this product anymore if I'm not making it, this overhead is just going to shift to whichever products I'm making elsewhere in my facilities. So this $13 is irrelevant. It means that this $13 is going to be incurred whether I make this product or whether I buy it. Now, of course, if I buy it, I'm not going to apply the $13 to this particular product. I'd apply it elsewhere. But the key is for the company on a consolidated basis, this cost is irrelevant. It does not differ. We incur it no matter what. So because it's irrelevant, I'm not going to include it down here. It's not avoidable, so it's not a differential cost. When I add up these columns, the total differential cost here is $25.40 to make it, $32 to buy it. When I calculate the difference per unit between my differential costs, I have a per unit difference of $6.60. It's cheaper to continue making it. We could then multiply that by the number of units that we're making. I think it was that 14,300 units to get the total benefit there, $94,380. So in this case, just to go ahead and answer the next requirement, we should continue making this based off these first given details. Now I want to change this just so that you all who use the total cost approach can see how your approach comes up with the same answer. So first I want to change this. These are no longer going to be my differential costs, they are my total costs. So all this is is for my fixed manufacturing overhead. Okay. If I continue to make these, I'm going to incur $6 per unit. So I'm going to put that up there. On the other hand, if I'm buying these, I'm still going to have a portion of this cost that remains. It's going to be the 60% that remains. So I'm going to take this $6 and multiply that by 0.6. So I've got $6 here, $4 there. Sorry, let me show the decimals there. It was rounding to $4. It's $3.60. Now, remember when I was doing the differential approach, I just had $2.40 in this make column? Let's look at what happens here, and I'm just going to calculate it over here. If I look at the difference between my total cost of $6 minus the total cost to buy of $3.60, that's a difference of $2.40. So with my method, instead of putting $6 here and $3.60 here, I just cut to the chase and I put the differential cost, meaning what's the difference, $2.40, in this make column. I ignored the $3.60 that was irrelevant because no matter what, that $3.60 is in both of these numbers. Out of this $6, $3.60 is related to depreciation, and then we can see that $3.60 right here. Also in this $6 is the relevant cost of $2.40. So, rather than having the $3.60 on each side of those, with the differential approach, I ignore each of these, the $3.60, and I just cut to the chase and I only put the differential amount here of $2.40. So either way, I'm going to come up to the same total difference, just a different method. So I'm going to drop those back in here so you can again see how that works. Now for fixed manufacturing overhead, I could put the 13 here, and I could put the 13 here, because that cost, no matter what, is going to be incurred, so it's part of my total cost either way. And you can see here I've got my total costs. That's just adding up these columns. Again, if I copy this formula and I'm looking at the difference between what's in my make column and what's in my buy column, it's $13 either way. No matter what I do, I will incur this cost. It's either going to be incurred and allocated to this specific product, or it's going to be incurred for the company as a whole. So because it's the same either way, it's irrelevant. It's irrelevant because there's no difference between my two options. So again, when I was using the differential approach, I didn't put $13 on either side because it's the same either way, therefore there is no difference, so I simply ignored it. You can see here I then added up the total cost to make, the total cost to buy, and I calculated the difference of $6.60. I come up with the same answer. You can see here the total benefit to make is still a total benefit of $94,380. Or sorry, $94,380. This was using the total cost approach versus what I originally had was the differential approach. I prefer the differential approach just because I think it's more straightforward. You ignore all the excess. But if you like the total cost approach, there's nothing wrong with using that approach. You do, though, need to be careful that you title things appropriately. I'm going back and changing this back to my original method, so I changed that back to differential cost, and I'm going to drop that $2.40 in there. So either way, same answer, but the wording, it does matter. On a test, if I ask you for the differential cost to make is $25.40. On the other hand, I could ask you for the total cost. The total cost to make, let me put that back in there, is $42. Just be careful with your wording and be sure that you understand differential cost versus total cost. So moving on from there, we're going to change something. Suppose that if we decided to purchase these, we've got a lot of excess capacity in our plant, and we can use that excess capacity to launch a new product. And they tell us if we launch this new product, it's going to bring in $99,000 $380 additional dollars per year. So we've got to think through this. How do we get this extra $99,380? We get this only if we choose to outsource. We only have the free space if we choose to outsource. So if we continue making this product in-house, we're giving up this extra $99,380. If you have to give something up to do something, that is an opportunity cost. And this is an opportunity cost that we will incur if we continue making this product in-house. So the way that I calculated this is I understood that I already calculated my costs above. So the cost above, using my differential cost, the cost to make these, the differential total cost to make these, is $363,220. All I did was take my differential cost and multiplied that by the total number of units that I was making. That's the total differential cost to make these. The total cost to buy them was the $32 multiplied by $14,300. Now again, had you used the total cost approach, your make and buy numbers are going to be different. But again, we're not looking at the cost in total, we're looking at the difference between the two. So again, even if you use the total cost approach, your difference down here is still going to be the same. The opportunity cost to make it, this is an additional cost, so it increases the cost of making my product. The cost of making my product in total, so this differential total cost to make, is $462,600. The cost to buy has not changed. It's still this $457,600. So now the cost to make is higher than the cost to buy. So now I've got a benefit of $5,000. The benefit of $5,000 is just the difference between these two items. Okay, and it's a benefit of $5,000 if I choose to buy these. Now, I just want to prove to you again, total cost approach, differential approach is going to come up with the same answer, but I just wanted you to see how that was. So again, I'm going to put the $6 in here. I'm going to put the $3.60 here, the 13 here, and the 13 here. Okay. Again, you can see here, I've got my total cost to make, my total cost to buy. I added that opportunity cost, and again, all I'm doing is comparing the total cost to make, the total cost to buy, and I have that difference of $5,000. Now, one other way I saw people solving this is they were using the total cost approach, but they were leaving off fixed manufacturing overhead, so they were leaving this off altogether, which again, as long as we leave it off on both sides, it's fine. You can see our total costs here. We've got the difference for either method, $6.60, still the same. When we come up with the opportunity cost here, we're using this cost of $29 and $35.60 per unit. And then we're adding the opportunity cost and again looking at the difference between our total costs here. And we've got that total difference of $5,000. So there's more than one way to tackle this problem. And you can see that we've gone through those. But again, pay attention to understanding what is a differential cost versus what is a total cost, because the terminology does matter in terms of if you were asked to calculate specifically a differential cost or if you were asked to calculate a total cost. This specific problem didn't ask for you to calculate those costs. It asked you to calculate the difference. So either method is appropriate, but do be careful with understanding the wording.